Alright guys, so today we're going to talk about finding the equation of a perpendicular bisector. So let's start a little bit talking about what it is that we're looking for. So what I want you to understand is the shortest distance between a point and a line is the perpendicular distance. So if this were a line just drawn with a point out here at random, I want you to know that the shortest distance between there is the perpendicular distance. And that distance is the length of the segment perpendicular to the line through a point. Okay, so what I've done to this line is put some points on it, A, B, and I put I here for intersection of our perpendicular line. Okay, so at this stage of our notes, what I would do would be to stop the video and write down these steps. So guys, these are very long problems to solve with a lot of point or weight on the question, because you're essentially doing every single step that we've done in the past two lessons on this one problem. So let's look at that. If you're given the points A and B for the line and the point P, these are the four steps you're going to go through. First, we're going to find the equation of the line L. So that's just finding the equation of a line using 2 points. This is the first lesson of this unit. Second step, find the equation of the perpendicular line through the point P. This was our second lesson in the second video that I posted. So essentially, this is the only step that's new to us because we have done systems in the past 2 units. So we're going to use systems to find the point of intersection, which we're going to label as point I, and then we're going to find distance between point I and point P. Now guys, distance comes from the very first unit, the Algebra 1 review unit that we have done this year. Okay, so let's look at this seems very wordy, and if you're like me, if you're a math person, I want to see it put into work. Okay, so let's look at what an example would look like. So guys, all it's going to do, it's just going to give you line L and tell you the 2 points, and then it's going to give you point P. So for my visual learners, sometimes it helps us if we draw a line putting those 2 points, 4, 3, negative 2, 0, and here's our point P out here at the point 3, 10. Again, just giving you a visual because we're trying to find the equation of this line between point P and the given line. Okay? So step 1 told us to take those 2 points and find the equation. Guys, remind yourself, to find the equation of a line you need 2 things, a point and a slope. So we're going to take these 2 points, find the slope, and the slope of that line will be 1/2. And you're going to take that 1/2 and you're going to pick one of these, either the 4, 3 or the negative 2, 0, and you're going to plug it into point slope formula. So y minus my y value of 0 is equal to my slope times x minus my x value of my point. Distribute the 1/2, and of course if we add 0 to both sides, we get the same equation. So we want our equation in slope-intercept form. Step 2, this is very important. We're going to write the equation of the line perpendicular to line L, but now this time we want it to go through point P. Alright, so remind yourself, the slope of line L was 1/2, therefore the perpendicular slope will be opposite and flip. So it will become a negative 2/1. So you're going to use that perpendicular slope and the point P in point slope formula. So all of these skills are essentially very easy. They're Algebra 1 skills. The hard factor comes in when you're trying to determine which point and which slope to use. So write these notes as detailed as you can. We're wanting to use the perpendicular slope and the point P. So y minus my y value is equal to my perpendicular slope times x minus my x value. Distribute your negative 2 and put your equation into slope-intercept form. Those are the 2 skills that we practiced on the first 2 lessons of this unit. Now, what you're going to do, you're going to take those two equations, and those are the two equations that we're going to use for step 3, which is systems. So in your notes, write what you're doing. We're going to use systems to find the point of intersection between the two lines. So here was my first line, 1/2 x plus 1. Here was my second line, negative 2x plus 16. So when you think about systems of equations, think elimination or substitution. So we can very easily eliminate the y by just simply multiplying one of the equations by negative 1. So when you do that, it becomes negative y equals positive 2x minus 16. The y's cancel. 1/2 plus 2 is a 2.5. 1 minus 16 is a negative 15. Add the 15 to both sides, divide by 2.5, and we get x is 6. We can take our x and plug it into either one of these original equations. 1/2 of 6 is 3, plus 1 is 4. So guys, we now have our intersection point of 6 and 4. Notice that I wrote my answer as an ordered pair. Guys, this is an intersection point. Do not just box in your x and box in your y. No, no, no. I want you to understand that what you found is the intersection point of those two lines. So write your answer as an ordered pair. Now, step 4, however you need to put this in your notes, please understand that you're using point P and the intersection point of 6, 4. So give me just a second. I'm going to slide back up here. Here's point P at 310, and we have found this point right here to be 6, 4. That's why you have to use those 2 points. We're trying to find this distance between the two. So the distance between 3 and 6 is 3, and we're going to square it. The distance between 10 and 4 is 6, and we're going to square it. 3 squared is 9, 6 squared is 6 squared is 36. Added together is 45, and we can simplify our radical by breaking it to 9 times 5, which is 3 square roots of 5. So again, 4-step problem, because this is the answer. That is the distance between our point and the line that was given. But the problem, or not problem, but the hard part comes from remembering which point to use when to get that equation, okay? So we're going to do one more example like this. Because they're so lengthy, we don't give too many examples in class. Your homework tonight will be 5 examples from the book. So we're going to give, we give those on a block day typically. Because they are very lengthy problems, we only assign 5, because that way we can address several different things that you might see. So this homework is extremely important, okay? All right, here's our second example. Line L contains 2 points, and then it's giving us point P of 4, 1. So remember, your first step is to find the equation of line L. So we're going to take these 2 points and find the slope. Our slope is a negative 1/3, and in this one I have used the point negative 6, positive 1. So I plug in my slope and I plug in my point, and I get the equation of the line to be y equals negative 1/3 x minus 1. Now at this point I would stop the video, work step 1, see how we did, see if you're getting what I am. Step 2 says to write the equation of the line perpendicular to what we just found, and we want it to go through point P. So guys, can you see how I'm illustrating through point P? Because this is the most missed step right here. If our slope was a negative 1/3, then our perpendicular slope is going to be a positive 3. So we're going to use this perpendicular slope and the given point of P in our point slope formula. Here's my perpendicular slope, here's my x, here's my y, excuse me, and we're going to put our equation into slope-intercept form. Guys, those two, notice how I highlighted those? Those two are extremely important because if you miss either one of those steps, then when you go to set up your system, your equations are off, which is going to throw off your point of intersection. So notice I'm using the equation from step 1 and the equation from step 2, and I'm going to work it the exact same way that I worked the last example, in that I'm going to multiply this equation by -1 so that my y's will cancel. So when I do that, I get a negative y, a negative 1/3, and a negative 1. Y's cancel. 3 plus 1/3 is 10 over 3. Negative 11 plus 1 is a negative 10. Add the 10 to both sides. Multiply by the reciprocal to get x is equal to 3. Take your x, plug it into one of the original equations. 3 times 3 minus 11 gives us a y of -2. Notice that I'm writing my y as an ordered pair. Okay, this is an intersection point between a point and a line. So it needs to be written as an ordered pair. And then from there, I'm using the point P and my intersection point and finding the distance. So guys, remember the distance formula is that very long formula, x2 minus x1 squared plus y2 minus y1 squared. I've always shown the shortcut in that if you think about them on a number line, the distance between 4 and 3 is 1, and we're going to square it. The distance between a +1 and a -2 on a number line is 3 units squared to give us the square root of 10. Guys, you're more than welcome to use the formula and plug in your x and y values, or you may use the shortcut. Either way is acceptable. So your homework tonight comes from page 221, and these are 5 problems designed to be worked in the 4 steps like we show above. But what you're going to see is that sometimes you get slopes of vertical lines or slopes of horizontal lines, so it throws a different factor into your equations. So these are extremely important because they carry a lot of weight on your test.